Problem number 6. At time t equals 0, a drag racer starts from rest at the origin and moves along a straight line with the velocity given by this expression, where v is in meters per second and t in seconds. The expression for the displacement of the car from t equals 0 to time t is what? So we need to find displacement for time t. We know that if we have graph velocity versus time, and we draw this curve, that's parabola. So to find what is total displacement, we need to do integral. That's the area under curve, and we just need to know how to do integral from polynomial function. I can remind you, this is like this: t power n dt from 0 to n to t, that's equal 1 over n plus 1 t power n plus 1. So this is how to find integral from polynomial function. In our case, displacement, that's such integral. So that's equal, using this formula, that's 5 over 3 t power 3. So that's the answer. From the left side we can choose the right answer, that's B. Problem number 7. The chemical potential energy stored in a battery is converted into kinetic energy in a toy car that increases in its speed from 0 mile per hour to 2 miles per hour. And the next, from 2 miles per hour to 4 miles per hour. Ignore the energy transferred to thermal energy due to friction and resistance compared to the energy required in the first case to energy required to increase speed from 2 to 4 miles per second. So the formula for kinetic energy is K equal 1/2 mv square. We see that in first case we are taking energy, let's say with a speed v0, and next with a speed 2v0. So we have k1 equal 1/2 mv0 square, and k2 equal 1/2 mv0 twice. So we see that the kinetic energy K2 4 times greater than kinetic energy K1, but we need to find what is K2 minus K1 and compare this amount to K1. So that we see that that's 3 times more. So the answer is D, 3 times. Problem number 8. When two stars are very far apart, their gravitational potential energy is 0. It's a regular assumption for potential energy in gravity forces. When they are separated by distance d, the gravitational potential energy is U of all this system. If the stars are separated by distance 2d, so what is potential energy? we just need to write the expression for potential energy. That's equal negative G m1 m2 over d. That's the first case. Second case, we are increasing distance 2 times, so we have u2 equal negative G m1 m2 over 2d. And we see that in second case potential energy twice less than in first case. So the answer is this one. Problem number 9. A large wedge rests on a horizontal frictionless surface as shown. A block starts from rest and slides down the inclined surface of the wedge, which is rough, so we have friction between these two objects. During the motion of the block, the center of mass of the block and wedge moves somehow, and we need to move to find how it will move. So we have 5 options. First option does not move. Second option moves horizontally with increasing speed, with constant speed. C moves horizontally with increasing speed. D moves vertically with increasing speed. And E moves horizontally and vertically. So first we can conclude from this problem that this surface is smooth. There are no friction between surface and this wedge. It means that we don't have any force, horizontal force on this system. And it means that we don't have any horizontal acceleration. So it means that if center of mass of this system was in rest, it will stay in rest and after beginning of motion. Next one, because we have motion, it means that this block moving to the left and this wedge moving to the right. It means that center of mass of this wedge not moving vertically, but this will move vertically. It means that common center of mass, whole system moving vertically down with increasing speed, moving with acceleration. So that's the answer. We don't have any motion horizontally for center of mass. It stay and it moving vertically with increasing speed. So the answer is D. Moves vertically with increasing speed.